Alright, so for these first ones, 1 through 6 over here, and I'm sorry about that little guy right there, it's just being a pain. Basically what it's asking us to do is to match up the conservation of momentum equation with the scenario over here. So let's go ahead, let's just start reading these one at a time. So a car speeds up. So it doesn't say the car was at rest, so we're going to have some kind of momentum before, and then it's going to speed up. So there's going to be some impulse from the acceleration that would cause it to speed up. So if we look at all the different choices where we have momentum before, it won't be minus an impulse, it will be plus an impulse, will give us the momentum afterwards. So number 1, this should be D. Okay. Number 2, a person running catches a football. So the person's running, he's got momentum before, and he's going to join up with another object, that football that was thrown to him. That's how he catches it. That football also has momentum, and then they're going to basically collide and stick together at the end and have their own momentum. So of all the different choices here, F looks like it's the best one, where here we have the momentum before of the person running, here we have the momentum of the thrown football, here we have the momentum of the person and the football after it's been caught. So 2, we would say this is F. Okay, 2 moving cars hit and bounce off each other. So the fact that 2 cars are moving, each car has momentum, they bounce off, so they don't stick together. So we're going to have 2 things with momentum in the first place and 2 things with momentum in the second. The only one that matches that criteria would be down here at E. Okay, a moving airplane drops a bomb. So here the moving airplane with the bomb in it, 2 things moving together. Once the plane drops the bomb, now they're 2 separate objects, each with their own momentum. The only one that we see where there were 2 objects at the beginning which split into 2 at the end would be A. So number 4 up here would be A. A rocket at rest turns on its engine, hot gases go back, and the rocket goes forward. So this would be where we have initially, it's at rest, so there is no momentum. Gases go one way, rocket goes back, momentum has to be conserved because initially there was 0. So C would be the correct answer here. And then for this one here, it says a moving car uses its brakes to stop. So moving car, we've got momentum, uses its brakes, that's a negative force because it's opposing the motion, and it stops. So at the end, when there's no velocity, there's no momentum, so it would be B for this one. Alright, so let's take a look here. Here we've got the problems 7 through 8. Which has more momentum? These are kind of easy. Which has momentum? Fast baseball, slow baseball. Well, the mass on these is going to be the same, so obviously the one with the fastest speed would have the most momentum. Okay, a bowling ball or a baseball with the same speed. Obviously their speed is the same. Momentum is mass times velocity, so it would be the bowling ball that has the most momentum. A slow ping pong ball or a house, which one has the most momentum? Okay, this is where momentum is different than inertia, because a house, its velocity, unless you are traveling down a road, is 0 meters per second. So it's going to have no momentum. So even though this is a tiny slow object, it's going to have more momentum. Last question here, what does an impulse equal? Well, an impulse equals force times time, or it also equals just the delta P, the change in momentum. So these are problems 1 through 8. Questions 9 through 13 we will do next.